Hey gang, Brainy Nerd Tutor here, and in this video we're going inside the atom to see what it's made up of. We'll learn about ions, isotopes, and symbols. Now this is crucial knowledge in order to do well in chemistry. Last video in this introductory series was an introduction to chemistry and matter, which is a great starting point. So if you haven't watched it yet, check it out. You can do well in chemistry if you stick with it, so hang in there, let's go. Atoms are, well, small. And if we imagine a grapefruit, and if that grapefruit was the size of the Earth, then an atom would be the size of a blueberry. That's very small. So the word atom comes from the Greek word atomos from 400 BC or so, which means indivisible, or cannot be divided into smaller parts, because at the time, for those who believed in atoms anyways, they believed that the atom was the smallest form of matter. But nowadays we know that atoms are made up of smaller particles, subatomic particles actually. So let's check out an atom up close. There is a nucleus, which is comprised of protons and neutrons, and those are held together by a force called the strong force. There's also a third particle called the electron, which sort of hangs around the outside of the nucleus. The nucleus makes up most of the mass of the atom. Indeed, a proton is about 1,800 times heavier than an electron. And protons and neutrons have approximately the same mass. So most of the mass in the atom is due to the protons and the neutrons. Now, protons and neutrons are called composite particles because they're made up of smaller particles called quarks and gluons. But in introductory chemistry, actually in most chemistry, we're not concerned about those particles. We're mostly concerned about the electrons, the protons, and the neutrons, and mostly just the electrons and protons. The electrons are held near the nucleus because they are attracted to the protons. And electrons have a negative charge. That's a negative charge of -1. Now, technically, it's -1 times E, where E is the elementary charge of 1.6 times 10 to the -19 coulombs or so. But I wouldn't worry about that. Just for now, at a very introductory level, where the electrons carry a -1 charge. Each electron carries a -1 charge. And each proton carries a positive charge of +1. Technically +1e, but we'll just say it's +1. Neutrons, as you may guess, are neutral, so they have no charge. The negatively charged electron is attracted to the positively charged proton, just like how magnets of opposite poles attract. And similar charges, that is, charges of the same sign, repel each other. So protons repel each other because they're all positively charged. Now they can stay in a close confined area in the nucleus because of the strong force. And electrons repel each other as well if there's multiple electrons around there. Now we know that the mass of an atom is due predominantly to the nucleus, the mass of the protons and neutrons in the nucleus. But what gives an atom its size? Well, as you can see, the electrons out here, so the size of the atom is predominantly due to how far away the electrons are from the nucleus. And there's a lot of space in between the electrons and the nucleus. In this cartoon, it doesn't really do it justice. If the size of an atom, and again, defining the size of an atom has approximations, which we'll talk about later, but just for there isn't a definite size 100%, but we'll just say that this is the size of the atom just for now, keep things simple. This was the size of the atom, and if this size of the atom was the size of a football field, then the nucleus would be the size of this player's pinky toe. And actually, it'd be a magnitude smaller. So that's actually not really the best analogy, but that's what they give in the textbooks. Be significantly smaller than this player's pinky toe, with the electrons as far away or even farther away from this this football field here, and they would be extremely, extremely small as well. So there's a lot of space in there. And how do these electrons go around this nucleus here? Well, I did a little animation here, and the electrons, they buzz around the nucleus, attracted to the protons, right? Because the protons are positively charged, the electrons are negatively charged, so they're attracted to the nucleus, but they don't just go right into the nucleus. The electrons behave as waves and not just particles. So this picture isn't totally accurate because in reality, we can't pinpoint where an electron is at any specific time precisely. We can only say approximately where an electron is. And we can't say where an electron is going to be precisely. We can just give a general idea of where the electron may exist. So it buzzes around the nucleus. It sometimes exists inside the nucleus. Electrons are indistinguishable from each other. This is based on quantum mechanics principles. And we can't say an electron is here or there, but we will discuss that and give approximations later. Electrons, you may have heard this before, they exist as an electron cloud. So rather than just pinpoints pinging around like this, just think of them in almost all places at once, existing as a big, as a negatively charged cloud, acting as particles and waves around this. It's pretty cool. Now let's talk about ions. An ion is a charged atom or molecule. And there's two types of ions. You could have a cation ion, which is a positive charge. Cat means positive, ion means charge, and a positively charged ion. And if you like equations, the equation for a charge equals, to calculate what the charge is, it's the number of protons minus the number of electrons. So in this example here, the protons are red. So the charge equals 3 protons minus 2 electrons, which is a charge of +1. Now, I should mention, what does it mean by being charged? Well, charged means that the atom has an imbalance of either electrons or protons. So there's either one more proton or two more protons. We don't have the same number of electrons as protons, therefore there's a charge on that ion. Now, the ion could also be negatively charged, and that's called an anion. An is negative. And remember, ion means charge. And if we look at this example here, we can calculate the charge on this atom, or ion. This charge is equal to number of protons, which is 3. There's still 3 red protons here. 3 minus number of electrons. There's 1, 2, 3, 4 electrons. 3 minus 4. So the charge is -1. It's nice and pretty to draw atoms like this, but we often write them in atomic symbol notation like this. And the X represents the type of element, or type of atom, which is the element, type of atom. And we call that an element, loosely, by saying the type here. And now there's some numbers here. This number here, the subscript that precedes the symbol X, this is called the atomic number. Atomic number. It's often signified as a Z, or if you're not in Canada, a Z. And the atomic number represents the number of protons that the atom has. Number of protons. This number here, the 7 in the superscript, that tells you how many nucleons or how many particles there are in the nucleus. So this is the number of protons, number of neutrons plus number of protons. And that's often called the mass number, because the mass of an atom is predominantly due to the mass in the nucleus. Now that's often abbreviated as a capital A. There, the mass number. And then on this side, this is 1 minus or negative. We often put the negative after, but it's the same as saying -1. This represents the charge on the atom, and it's often represented as a capital Q there. So these are atomic symbols. This X here, that represents the type of atom or what element the atom is. We call this the the element symbol. The element symbol. Good. And this is the atomic symbol for this ion right here. So if we look at the periodic table, just going to move that away. This is the periodic table, and this shows all the different types of atoms, of elements that we know about, all the different types. And here, these numbers at the top, number 1, number 2, number 3, number 4, that's this number here. This is the atomic number. Atomic number. So this represents how many protons the atom has. And the X here, the element symbol, that's this symbol right here. So H would be the symbol for an atom that has 1 proton. Here we have 3 protons. So the elemental symbol is Li, Li for lithium. So it has 3 protons, mass number is 7. So this is a lithium ion, or a lithium atom, and it has a charge of -1 because there's 1 more electron here. So if you notice, there's numbers at the top of the periodic table. These numbers go in order. Now we're going to do an introduction to the periodic table next video, but for now, just these numbers at the top represent the atomic number, represents the number of protons in that element. The distinct number of protons gives you a distinct element. So for example, if the atom has 5 protons, then it's boron. It's the boron element. If it has 6 protons, it's carbon, that sort of thing. But if it has a different number of neutrons, it's called an isotope. Isotopes are atoms of the same element. They have the same number of protons, so the same Z, the same atomic number, but they have a different number of neutrons. And here's an example here. So in this atom here, there's 1 proton. There's 1 proton here. Here's the atomic symbol. And the elemental symbol is H. If I just go back to the periodic table and look at what 1 proton is, 1 proton here, elemental symbol is H. H stands for hydrogen. So this is a hydrogen atom, and there's a 1 in the mass number because there's only 1 proton plus neutrons. 0 neutrons, 1 proton, so there's 1. If we add a neutron, it's still hydrogen because it still only has 1 proton. So remember, the proton tells you the type of element it is, the type of atom it is, but it's a little bit different than this one. It now has a mass number of 2 in here. And then this one, we add another neutron. It still has 1 proton, but it has now 3 nucleons, 3. So 1 proton and 2 neutrons. So its mass number is 3. These are all hydrogen atoms, but they are isotopes of hydrogen atoms. Now, generally, isotopes have the same chemical properties. They're the same element. They have the same reactivity. If you go on in chemistry, you'll learn that there's slight differences in reactivity in isotopes, namely how the speed of which they react. But for the purposes of this introductory course, isotopes, they react the same. So we went deep inside the atom. We defined the parts of it. We discussed charge, ions, symbols, and isotopes. And the last video of this series has a practice exam where I go through questions. So be sure to watch it to the end so you don't miss anything.